I'm Yan Hong. Now let me introduce our open source library, MMagic, for the research of multimodal, advanced, generative, and intelligent creation. Here is the outline of my today's talk. The first part, I will give an introduction to MMagic, and then we will show some quick start with MMagic. So I think the first question is, why should we use MMagic? I think the answer comes from the variety of tasks supported in MMagic. Specifically, originate from editing. MMagic supports many different low-level tasks, including image matching, image deblurring, and also image super resolution and image colorization. And also for video enhancement tasks, including video frame interpolation, which can make your video smooth. And here is an example of video super resolution. I think these techniques have been widely applied and improved our daily life a lot. So far, MMagic has helped our community users to win at least 10 champions in the top academic challenges. Besides, MMagic also supports many generative tasks, including image generation such as style gun, and also novel view synthesis by EG3D, and also for the recent popular topics, including text-to-image generation, which mainly based on latent diffusion model, and subject-driven image generation, which is also known as customization image generation, and also for controllable image generation, which aims at adding more controls to the foundation generative models. For video tasks, users can also explore the task of text-based video editing based on the powerful text-to-image generative foundation models. In this case, users can use ControlNet and multi-frame rendering techniques or some attention injection technique to render different styles or edit the specific attributes for the original videos. Recently, we also have supported Animate Diff, which is a recent popular text-to-video model in our library. And in this case, we show that with MMagic, we can also translate the original photorealistic video into a cartoon style. And then with the powerful segment anything model, we can specify any parts we want to edit and then edit them. For example, we can replace the background into another background. So, in a word, MMagic is an open source library that supports many different generative models. With the powerful generative models, it supports more than 20 kinds of tasks, involves more than 50 algorithms. MMagic provides more than 200 configuration files for easy training and easy testing, as well as about 200 pre-trained model weights. I think MMagic provides a unified user experience to easily test and train state-of-the-art research works for various tasks. So, if you are starting on low-level tasks or generative tasks, especially diffusion-based related tasks, or combining them together, don't hesitate to start with MMagic. And then the second question is how to use MMagic. Now I will briefly introduce the overall design of MMagic. As we know, a deep learning framework consists of several important components. First, we need to specify the dataset we used for training and testing. And then we need to design our model for our task, and also an evaluator, which can help us to save the best performance checkpoint during training. And we also need an optimizer to update the model's parameter, also a scheduler to update or to adjust the parameter of the optimizer. All these things are organized and managed in a runner in MMagic. And then we use hook to easily plug in our customized operation in any data flow. All these things can be recorded by our specially designed logic module and also our visualizer module to visualize anything we want during training or testing. And as we know, all these things may contain many different and complicated settings. We can manage them in a configuration file, and all modules with the same functions are managed by a registry mechanism. Here is a simple installation guideline for MMagic. In conclusion, to install MMagic, we need to first install PyTorch and also MMCV and MMengine, which provide the basic modules used in MMagic. Then we can install MMagic simply by pipe install. Also, if you want to experiment the latest developed version of MMagic, you can just clone our latest GitHub and to pipe install it from the source. And here is the second part of my talk today. It's a quick start tutorial of MMagic. Here consists of 4 examples. Play with stable diffusion, speed up stable diffusion with toolbox, customize stable diffusion with streamboot, and also control stable diffusion with ControlNet. And here is the first example, play with stable diffusion. And here is an overview of the latent diffusion model. So let me first briefly introduce stable diffusion. Stable diffusion is a latent diffusion model that enables people to generate any images they want by text prompt. There are 3 core components. First, the pink region denotes the pixel space. There is a VAE model in the pixel space, which is used for image encoding and decoding. By encoding images from pixel space into latent space, it can significantly save computation cost. And then the second part is the green part, which denotes latent space. In the latent space, there are 2 processes. In particularly, the diffusion process is used to add noise to a clean latent, step-by-step into a Gaussian noise. And in the denoising step, we trained a denoising unit, which inputs a time step embedding and the noisy latent to predict the noise. And finally, we can turn a randomly sampled noise into a clean latent, which is finally used to decode into image. And the third part denotes the conditioning part in the right part. Conditions such as semantic map, text, and representations images are encoded and input through the cross-attention module. And during inference, classifier-free guidance sampling mechanisms are used to generate samples based on a text condition. I think maybe the introduction of stable diffusion can be kind of complicated for people who are not familiar with stable diffusion. But with MMaigc, playing with stable diffusion can be very easy. Here we show, okay, to play with stable diffusion, we first need to initialize the working scope as MMaigc. Actually, you can also initialize the working scope as MMdetection, MMpretrain, and any other OpenMM libraries to easily use their modules. And then we show 3 ways to play with stable diffusion in MMaigc. First, on Python code. That means we need to set everything in Python code style. For example, we define all the details we used as dictionary here, such as the diffusion scheduler. We use DDIM scheduler, and we set the parameters in this dictionary slipped. And also we need to define the unit structure, the VS structure, and then we need to pass all these parameters into the models directionally. So after define all the things, all the details of models in dictionary style, we just need to use models to build our model. So in these 4 lines, we are able to build our stable diffusion model and then pass the text prompt into the model to get our image result. In order to manage and reuse all these configurations for different models and tasks, we have provided all these default settings in predefined configuration files in the format of Python or YAML. So you just need to load the configuration files here instead of specifying everything in the main Python code. So from the provided configuration file, you just need to 6 lines of code to play with stable diffusion. And also, we have developed easy-to-use API presented as influencer. So here we just need to initialize MMaigc influencer and specify the model name as stable diffusion. Then we can just pass our text prompt into the influencer to get the generated image. And then I think many users are suffering from long influence time of stable diffusion. So many researchers have studied on improving the efficiency of stable diffusion. Here, Toki is an amazing work that speeds up diffusion models by exploiting natural redundancy in generated images by merging redundant tokens in attention operations. As shown in this figure, the left part is the classical transformer unit block, and the right one is the unit block with token merging. So in every attention operation, we will first merge similar tokens before the attention operation, and then we unmerge it after the operation, so that we can save many computation costs during attention operation. To enable such a speed up operation in stable diffusion, we just need to pass the parameters of Tommy configuration here. Here I show two screenshots. The left one is the original Stable Diffusion configuration files, and the right one, in the right one, we only need to enable Tommy by one line of setting. So now the Stable Diffusion model is enabled with the Tommy operation. So here, we also need to build the model by models, and then we influence, we conduct influence operation by just put the model through the CUDA and then get the result. And here is the result compared by ours with about 1500 ratio of merging. We can greatly reduce the influence time. And here is the quality of different merging ratio. With 1500 merge ratio, I think the result is comparable with the original one. And customized stable diffusion is another hot topic in image generation. Customized stable diffusion aims at providing 3 or 5 personal photos and then fine-tuning the model to generate the specified concept with new context. And to enable customization in stable diffusion, we just need to load the stable diffusion configuration here as we showed before. And to enable it, we just need to specify the model type as string booth. And we need to set the prior loss weight as 1, and also the class prior prompt used or introduced in that paper. And also we have enabled training dream booth with LoRa, which means we don't need to fine-tune the whole model weights of stable diffusion. We just need to add some learnable parameter to enable efficient fine-tuning. And here I want to show how to train the personalized stable diffusion here. We just need to define the pipeline, which means the image pre-processing process, and we need to define our dataset and the data loader here, and also some settings about optimizer and some customized hooks during training. And then just one line to set to start our training. If you see if you can see all these logs printed in your screen, it means you have successfully customized your own stable diffusion. And here are some results. And now let's go to the final part about control stable diffusion with ControlNet. ControlNet is a game changer in stable diffusion that enables people to add more controls into stable diffusion rather than just a text prompt, such as I think here is the canning edge and some pose. To enable your own ControlNet in stable diffusion. Also, we need to load the provided ControlNet configuration files here. Here we need to specify the model type as a control stable diffusion, and we can load any pre-trained weight we used in VAE UNet and also the ControlNet. We can use different ControlNet to load different conditions. And here is the test result. We can also just use several lines to perform such a influence. How to train our ControlNet? I think all these things can be achieved in writing our configuration files. So we also so here we need to specify or just load the provided configuration file and modify it per your need. Here also are the classical steps, including image processing pipeline and training or testing dataset, data loader, and just one line to start your training. I think that's all for my today's sharing. Thank you.